and you're keeping track of them because you will be turning this in at the end once we have about 10 warm-ups on our sheet. So today is going to hopefully be a fairly straightforward day. We are going to start some notes on function families. Normally, I would teach this by having you guys do a card sort, but card sorts are kind of difficult to do online, and also they are difficult to, like, I want to teach you this stuff using the this chart. I don't want you to just have to try to figure it out on your own and then be confused. So this is the little chart that we're filling out. If you want to print this off, it is on Canvas. You can print it off. It also has the matching cards that you can print out and cut out and paste if you would like to do that. But what we're going to do, because we are online, is I'm just going to fill this in by writing it out. So if you just want to grab a sheet of notebook paper, make your own 4 columns and 4 rows, you can just fill this in with me as we go. I'm going to be writing it all out, so you can too. All right. So any questions before we start? Was there any problem with the homework, or are you guys okay? Okay. So we're going to start out by naming each of the function families that you guys, this honestly is a review. You should remember this from math too, but we're going over it because somehow every year everybody forgets. Okay, so we're naming each of the function families. The function families that we care about the most are going to be quadratic,
absolute value.
Yeah, absolute value. Then linear. And square roots. Okay, so we're going to write each of the parent functions for these families. The parent function means it's the function that represents this type of function without any transformations or stretches or compressions or reflections. Okay, so Roxy, are you there?
Yeah.
You can pick any one of these 4. How do I write it algebraically, like an equation?
I don't know.
Pick one of the families first.
Linear function.
Okay, so when I write out a linear function, what do I write?
Y equals.
I
don't know.
What's the most simple line you can think of?
3x.
Okay, so the 3 actually stretches it out vertically. So we're going to drop that and just write x. So y equals x is our linear parent function. Thank you very much, Roxy. Okay, Jerome. Oh, Jerome is sick and paying attention, but can't talk. Eddie, you can pick quadratic, absolute value, or square root. Which one would you like to do?
Quadratic.
All right, so for quadratic, how do I write the most simple quadratic formula or function?
Y equals x squared.
Perfect. Good job, Eddie. Thank you. Brandy, we have absolute value and square root left. Can you pick one? Brandy, are you here?
Sorry.
Oh, it's okay. Okay, so we have absolute value and square root. Which one do you want to do?
Square root.
All right, so a square root function, we're going to have y equals, and what's going to go over our x for a square root function?
Can you say that again?
What will go over our x in our square root function to make it a square root function?
A 2.
Not a 2. That would be like this quadratic function. We want the inverse of that. How do I get rid of a square?
You square root it.
Yeah, so we're just going to put a square root over the x. Good job, Brandy. Thank you. And Peyton, I need you to do the absolute value function for me.
Is it? I don't know. Hold up, absolute value function. I don't think I remember that, but let me think.
So we
Is
talked about it.
Is y equals dang. I
There's going
need
to be
the
an x.
help.
And
It's
there's
gonna be an x.
Yeah, and there's something that goes around the x. What is it?
Is it parentheses?
Not parentheses. They're a little straighter.
They're a little straighter.
Yeah, just these straight absolute value lines.
Oh yeah.
Good job. Thank you, Peyton. Okay, so now we need to draw the graphs for each of these functions.
Wait, Miss, can you slow down a little bit? I just got my binder out and I'm about to start writing it down.
I think that actually these are already posted, the completed notes. So if you need to pull up the completed notes and watch that alongside, they'll all be up there. And I'll try to keep this so that you can see it as we go. So for the graphs for each of these, we're just going to draw in a little x and y axis for each box.
That's tough. That's tough.
Okay, and these are notes, so I know Peyton's writing them down. I need everybody to be writing these down because you'll need to go back and reference this. All right. We have our quadratic function, and I forget who it was, but somebody said that a quadratic function kind of looks like a U, and that is correct. So the original parent function for a quadratic has its vertex right here at the origin and goes up like a cup and just kind of looks like a U. All right, it's going to go up on either side. Now our absolute value function takes the line y equals x, which looks like this, and it forces every single y value to be positive. This means that where the line would normally go down like this, I have to flip it up to the x-axis. So it's going to create this V-looking thing. Okay, and then we have our linear function. And that is just a positive sloped line that passes through the origin right here. Okay, and last but not least is the square root function. And the square root function is the inverse of the square function. So we would take this and we would actually reflect it over the line y equals x. And it creates kind of a sideways parabola. Now, if we were doing this all the way, we would maybe have like plus or minus the square root. But since we chose only plus, we only have half of that parabola present, okay? So we're going to have like half of a parabola on its side coming up from the origin for our square root function. Okay, so I'll give you guys a minute to copy those down. And then we're going to fill in tables, what it would look like to try to figure out what a table would be for each of these functions. Okay. Okay, what questions do you guys have so far on these notes? Okay. Since there are no questions so far, we're going to move on to the tables. So we have 4 different tables on this little grid of cards that we could put in. We need to figure out which one goes with which function. Was there a question?
Yes, it's paid. Can you go back for a second? I just need to get the last graph for the square root function.
So if you go back to Canvas, you can pull up the completed copy of the notes. That way we can keep working because we don't have too much time.
Oh, you could go ahead, hon.
Who are you calling Hun? All right. So we'll start off with these 2 tables right here since they're right next to each other and it kind of keeps the rest of the paper sort of visible. So we have one where our y value is undefined and for negative numbers, and we have one where everything turns out to be the same thing. Okay. So if we look at our graph, is there a graph that just doesn't have anything where we have negative x values? It has no part of its graph on the left-hand side of the grid.
The
So,
square root one.
yeah, who said that? Was that Juan? Juan, was that you?
I think that was Isai.
Oh, Isai, great. Thank you so much. So we have Juan's little screen was up. That's why I thought it maybe was him. We have this table where we have some undefined y values for negative values. That's because this function you can never put in a negative x value. So you guys should remember the property that we can't take the square root of a negative value unless we're trying to go into the complex plane and get imaginary numbers. So this table is going to map. So I'm going to have -2, -1, 0, 1, 2, and 3. And then we're going to have undefined for the first 2. And then we're going to have 0, 1, the square root of 2, which happens to be 1.414, and then the square root of 3, which is 1.732. Okay, good job.
Can you move it up a little bit?
Oh yeah, I'm sorry. Somebody told me in a different class that like there's a bar and it gets in the way on your screen and I just can't see it. Okay, so now we have this table. So it takes a number and maps it to the exact same number. Was there a question? Sorry.
Yes, it's a question from Peyton. What does that say? I cannot see nothing in that say on the wall. I just see 0 and 1. What does that say beside the 2?
I think it might be because my window is a little closed. Okay, does that help?
Yes, but what does it say? Can you tell me what it says?
It's supposed to, so it says undefined. I abbreviated it as UNDEF.
That's supposed to be on -2 and -1.
Yeah. Both of the negative values are undefined. Okay. So Betsy, let's look at this table right here. It maps every x value to a y value that's exactly the same.